All right. Hi, everyone. Today we are going to do section 3-5 in the book. Just a couple of announcements for you. First of all, you have until not this upcoming Monday, but the following Monday to complete the Systems of Equations quiz, which is one that we took last week. I'll be back on Monday to help you get that done. This Friday, we will have our Chapter 3 test. So that's kind of the next upcoming big thing. After this lesson that I'm going to teach today, there really isn't a lot of new stuff. So next week is going to be a lot of practice and a lot of just getting ready for the test. So I want to start today because I want to talk about what's happening when I'm finding the solution to a system of equations with two variables. And we know that that usually is the spot on the graph where two lines intersect. So this is where our solution is. And so when we're in two variables, so x's and y's, that's pretty simple because we have two lines that are intersecting and we're finding a place where those two lines intersect. The thing about that is today we're going to talk about 3-5, which is systems of three equations with three variables. And so in three variables, we're going to actually be looking for a point where three things intersect, just like we did on the last one, but now there's three with three dimensions. So just a quick little intro to points in three-dimensional space, and this isn't super important for our lesson or for knowing right now this year. It's just sort of interesting. I will just say this is different from how they do it in physics, and so just, it's just weird that it's different in physics. But what we do in three dimensions is we make our x-axis come towards us, directly at us. So that's what this axis is. This is our x-axis. And then our y-axis goes left and right. And so this is kind of like where we would think our x-axis should be. And then up and down is our z-axis. And so the point right here, this point, is the point x, y, z, where we have the x value, so that's how close we are to it. The y value is how far to the right or left, and then the z is how far up or down. And so what that means is in three dimensions, when you have x's and y's and z's in equations like this one, we have a plane. And so this triangle here is actually just a cross section of the plane. And so the plane, when I say plane, I don't mean the thing that flies in the air. I mean the surface, like a flat piece of paper that is oriented a certain way in three-dimensional space. So all these equations that we're going to be working with on the next couple of slides are just representations of planes. These pictures are all so grainy. Anyway, so the thing about planes is they can intersect in a lot of different ways. And so this one is the one that's going to be the most interesting to us, where they all intersect at one point. But like this one right here intersects, these three planes all intersect in a line. These three planes, 1, 2, 3, don't intersect at all. These two planes intersect here, and these two planes intersect here, but these there is no place where three planes intersect. These three planes are intersecting in one spot. This plane is the same as this plane, but then this one is different. So there's no place where all three planes intersect there. There's definitely no place where all three planes intersect here. And sometimes all three planes are just the same. And so there's a million different ways that can happen. Well, really, it's just 8. But there's a lot of different ways that these can come out. Basically, what you need to be able to do is find the ones that have one point as the solution and then recognize when one point isn't the solution. So sometimes there are infinitely many solutions, like these two or this one, right? These four options have solutions. These four options do not. And so I'll say no solution. Okay, that was a whole lot of just looking at pictures to understand that what I'm trying to do is I'm trying to find where these three planes intersect with one another and if they intersect in one place. So all of this is just solving systems of equations, but we have to do it kind of a really specific way. So what I'm going to do is I'm going to label all of these equations as numbers. So I'm going to say this is equation 1, this is equation 2, and this is equation 3. That's just going to help myself stay organized, and I would encourage you to do this when you're solving these systems yourself. When you solve these systems, you always have to start by eliminating one of the variables two different ways. And so what I'm looking at is I'm saying, okay, I look and I see that these three z's, I could find two different ways to eliminate that z. I could do it with x's and y's too, but it just looks like the z's are kind of the easiest ones because I don't have any coefficients to work with, and so I'm just going to go ahead and do that. So the first way is add equation 1 plus equation 2, and that's going to eliminate the z's. So I'm going to write that all out. 2x minus y plus z equals 4. And then the other one is x plus 3y minus z equals 11. And so we're going to add those together and we're going to get something. Okay. Let's see what we get. So we'll end up with 3x plus 2y equals 15. Notice that the z's eliminated. Okay, I eliminated the z one way. Now I'm going to eliminate the z another way, and the way that I'm going to do that one this time is I'm going to do equation 1 plus equation 3. So same equation 1, 2x minus y plus z equals 4, and then equation 3 is 4x plus y minus z equals 14. Now, what do I get when I do this? Well, I get, let's see, 6x, and then these eliminate and these eliminate, so that's kind of lucky, and then I get equals 18. Now, normally what we would have to do is we would have to solve this system of equations next, okay? And so that's what I'm going to do next. So I'm going to say this is all of step 1, by the way, just so that we're all kind of keeping track of where I'm at here. I'm just going to kind of label this as step 1. Okay. Step 2 is to solve the resulting 2x2 system. And so what I mean by that is I'm going to go and I'm going to solve the system that says 3x plus 2y equals 15, and then 6x equals 18. So this is step 2. Now, this one is actually pretty fast to solve because I already know what x is, or I can see it really pretty quickly. I can divide both sides by 6 here, and I can get that x is 3. That's nice. Now I'm going to take that and I'm going to plug that back in for x here, and I'm going to get 3 times 3 plus 2 times y, 2y equals 15. So I get 9 plus 2y is 15, so I'm going to subtract 9, and I get 2y equals 6, so then y equals 3 also. Okay, so now here's the thing. Normally when I'm doing step 2, I would feel like, okay, you know what, this feels like I'm done, right? This is step 2. But I'm not done yet because I still don't know what z is. So I have to go back, now that I know what x and y are, and plug that back in to get what z is. So I'm going to rewrite, and I'm going to just use equation 1. You can use any of the equations, but it doesn't really matter. I'm just going to use equation 1 because it looks simple. 2 times, and I know that x is 3, minus, and then y is 3, and then plus z equals 4. So I have 6 minus 3 is 3 plus z equals 4. So I can see that z has to be 1. Okay, so this is step 3, by the way. Lastly, I just need to rewrite my answer. I just need to write the answer as the point x, y, z, and that would be 3, 3, 1. And there's my answer. So I'm going to zoom out a little bit so you can kind of see the full screen of what we did. First, I eliminated the variables. I eliminated the z 2 different ways using 2 different pairs of equations. Then I solved the system of equations that resulted once I got those answers. And then I used those to put that back into step 3 where I'm solving for z. I'm finding the last variable that way. Okay, I'm just going to do one more example because I'm going to show that we can do this again a different way. And this time I know that it looks like it would make sense for me to eliminate a y, but I'm going to kind of challenge myself a little bit because I think it would be good for us to see how I could eliminate x in this equation. Because sometimes there isn't a variable that's super easy to eliminate, and when that happens, we have to have a little bit more like coping skills with that. So I'm gonna kind of put myself in a little bit more of a difficult position for this problem, and then we're gonna see that it will still work out. So I'm gonna choose to eliminate x, and the way that I'm gonna do that is I'm gonna take the first equation and I'm gonna multiply equation 1 times -2. And that's gonna give me negative 2x plus 2y minus 2z equals 2, okay? And then I'm gonna add that to equation 3 because that one has the 2x there. So I'm gonna put 2x minus y plus 2z equals 0. Added together. And I'm gonna get, okay, these eliminate, no, I'm sorry, they don't. These eliminate, and then I get y equals 2. Okay, good, I have something to circle and highlight and bring to my next step. The next step is I need to eliminate x another way. But in truth, I really did eliminate z also, so I could eliminate z again, and see whether that goes, or I could do the x. There's a lot of flexibility here, but what I'm trying to do is I'm trying to show a method that's gonna work for every step, no matter what strategy you choose, no matter what pairs you choose. So I'm gonna take equation 2 and I'm gonna multiply that by -2 also, and that's gonna give me -2x minus 2y minus 6z equals 6. And then I'm going to take equation 3 again. All that matters when you do this step is that you don't choose the same 2 equations twice. So I used equation 3 twice, but each time I used equation 1 with equation 3, and then I used equation 2 with equation 3. Okay, so equation 3 is 2x minus y plus 2z equals 0, and then I'm going to add those together. So I get negative 3y. These eliminate, by the way, and then I get negative 4z equals 6. Okay, so that's my second equation, and then I'm going to solve the system y equals 2 and negative 3y minus 4z equals 6. Okay, so this was step 1. Step 2 is going to be to solve this system, but I already know what y is, so I'm going to take the y and put it in for y. And I'm going to see what I get. Negative 3 times 2 minus 4z equals 6. I'm going to add 6 to both sides. And I get negative 4z equals 12. So then that means that z equals negative 3. Okay, so I know z is negative 3. I know y is 2. And then I just need to do step 3. By the way, this is step 2. Step 3 is just going to be solve for, I guess I need to know what x is, right? So I don't know what x is yet. So I'm going to do the first equation. It doesn't matter again, but I'm just going to use that one. X, and then I know that y is 2. So I'm going to write minus 2. And then plus z is negative 3, and then I get equals negative 1. So negative 2 minus 3, this part is negative 5, so I'm going to add 5 to both sides. I just want to make sure that's not a division symbol. Okay, add 5 to both sides, I get x equals 4. So there's my answer. My final answer, though, I need to write as a coordinate x, y, and z, and that would be 4 2, -3. And there we go. So again, I'm going to zoom out a little bit so you can see the whole picture here. This is a 3-step process, but each step takes kind of some work, right? So I'm going to label this as step 3. Be really careful. Take your time. Watch this video a million times if you need to watch me do these problems over and over again until you start to see how this works. You also have a practice assignment to do, and this is out of the textbook, and so everybody can use the textbooks that are in the back of the room today. Grab your textbook and work on the daily practice after you finish watching this video. My expectation is that you come to class with all of these problems done on Monday. I really need to see these in your notebook because I need to know that you've done the practice you need to do to learn how to do this material. These problems are not, it's just not possible to learn how to do these by just watching me do them. You have to practice it because it's a hard skill. It's something that's challenging. It's a lot of steps. It takes practice. And so I just need you to commit to doing the practice for the rest of the class. Otherwise, I have nothing else to tell you. I hope you have a great weekend, and I will see you again on Monday. So do the practice, and I'll see you Monday.